Emmett, so now we need to start with the unit 2, right? So first of all, if you're talking about the syllabus of unit 2, we've got 2 chapters, right, to cover. First of all, we need to do waves, and then we need to talk about electricity, right? Ji? In waves, we almost got 4 topics. And what are those 4 topics? We have got to cover the basic waves, right? The basic properties about the waves. And then we need to talk about the light, right? Then we need to talk about the properties of light, right? The properties of light waves. And after talking about the properties of light waves, the last topic from the waves is quantum physics. Is that fine, Amit? So we've got
Yes.
the basic of waves, we've got light, we've got the properties of light waves, and then we've got the quantum physics. So first of all, we need to start with the basic waves. And when you're talking about the basic of waves, first of all, you need to understand what the waves are. Ji Amit, how would you define waves? What are waves? Ji, how would you define a wave?
Uh,
Ji. Well, remember that wave is a disturbance produced in a medium, right? Wave is a disturbance produced in a medium which causes the particle to move to and fro about a point. ठीक है जी? So whenever you're talking
yes.
about the waves, waves is a disturbance produced in a medium which causes which causes the particles to move to and fro about a point. An example, if you're talking about the example, I mean, what could be the example of the waves? For example, you've got a pond full of water, right? And you're standing right over here, and you're going to throw a stone inside this pool, right? Due to
Yes.
this stone, the particles of the water inside the pool would start vibrating up and down or to and fro. ठीक है जी? That is how you talk about the waves. This is an example of waves. Okay.
Yes. Sir, can you repeat?
For example, you're throwing a stone inside the pond. ठीक है? That stone would create some sort of a disturbance in a medium, which is going to cause the particles to move to and fro about a point. Is that clear?
Yes, sir.
Right? So that is how you talk about the basics of waves. And then, as far as the purpose of waves is concerned, uh, Ahmed, what is the purpose of a wave? एक wave का purpose क्या हो सकता है? The main purpose of a wave is to transfer energy from one place to another, right? The basic
Yes.
purpose of a wave is to transfer energy from one place to another. Okay, ji? Now we need to talk about the types of waves. ठीक है? We need to
Yes.
talk about the types of waves. So generally speaking, whenever you talk about the types of waves, generally there are 2 types of waves. One of them is a mechanical wave, right? And then we've got an electromagnetic wave. Okay, ji? We've got a mechanical wave and then we've got an electromagnetic wave. How would you talk about a mechanical wave? GM, any guesses what is a mechanical wave?
Sir, the type of wave that type of wave that moves with the help of machines.
Not with the help of machine. Remember that
External
mechanical waves which require a medium for its flow, right?
Yes,
Whenever you're talking about the mechanical wave, it is a medium, it requires a medium for its flow. For example, if you would have been sitting right besides me right now, अगर आप physically इस वक्त मेरे साथ बैठे होते, how you'd be able to listen my sound waves? Because sound waves need air to flow, right? You cannot hear sound in space, okay?
yes,
So remember that example should be the sound wave. So sound wave is basically a mechanical wave. It requires a medium for its flow. That is how you talk about the sound wave. Is that clear?
yes,
Okay. Secondly, you have got an electromagnetic wave. The electromagnetic wave is just the opposite of mechanical wave. It do not require a medium for its flow, right? If a wave do not require a medium for its flow, then it is known as some sort of an electromagnetic wave. Is that clear, Jim?
yes.
Right? Ahmed, any examples for an electromagnetic wave which you think do not require any medium for their propagation? Ji, Ahmed,
Sir, radiation,
what type of a radiation? Radiation, but somehow like X-rays, right?
X-rays, yes,
Or alpha rays, or even you can talk about the micro waves. ठीक है जी?
yes,
So all of these waves do not require a medium for their flow, and that is why they are known as electromagnetic waves. And first of all, we have got some sort of mechanical wave. Is that clear as well?
yes,
Secondly, whenever you talk about a mechanical wave, for example, you have got some sort of a mechanical wave. So, Ahmed, whenever in this chapter, we are just going to talk about the mechanical waves in detail. Okay? हमने सिर्फ mechanical
yes,
waves की बात करनी है detail में. So mechanical waves, remember that there are further two types of the mechanical waves. One of them is the longitudinal waves. One of them is a longitudinal को आप compressional wave भी कहते हैं, right? The longitudinal
yes,
wave is also known as a compressional wave. And then secondly, we have got a transverse waves. So these are the two types of waves, and we need to talk about their differences, right? For example, you have got a very slinky spring whose one end is open and the other end is tied to a fixed support, and other end is tied to a fixed support, right? And what are you
yes,
going to do with this spring? You're just standing right over here and you're going to move this spring back and forth. You're going to move this spring back and forth, right? So after moving this spring back and forth, you'll see a pattern in the spring forming up, and that pattern should look like something like this. Did you get that? You can see
yes,
there is a part of wave where the particles are very close to each other, which is can also be known as a compression. And you can also see there is a part of a wave which got some sort of a rarefaction as well, right? The particles are very far away from each other. Then you'll see a part of the wave where the particles are very close to each other, so that is known as compression. Is that clear as well?
yes,
Right? So पहली बात तो याद रख लें कि longitudinal or the compressional wave are such waves, you know, such waves which are produced as a result of back and forth motion. right ji? Such a
Yes.
wave that which is produced as a result of back and forth motion is known as a compressional wave. Now, secondly, we need to talk about the transverse wave, right? Now, what is a transverse wave? Whenever you're talking about the transverse wave, you just need to remember you've got the same slinky spring. Slinky means a very loose spring, right? You are standing right up over here. You're grabbing one end of the wire and you're trying to move it up and down. And you're trying to move it up and down. Is that clear?
Down. Yes.
When you're trying to move it up or down, you'll see a pattern forming up in the spring that should look like this. Is that clear?
Yes.
Right? So this is known as a transverse wave. And how I'm going to define it, the very first definition of the transverse wave, such wave which is produced as a result of up and down motion, right? Ji? Such wave which is produced as a result of up and down motion. That is how you talk about the transverse wave. Is that clear, Ji?
Yes.
Right? So this is a longitudinal or a compressional wave, and this is a transverse wave. We can define them in one more way, and that way is, remember, the wave which consists of the series of compressions and rarefaction. Such a wave which is consisting of the series of compressions and rarefactions is known as a longitudinal or compressional wave. ठीक है जी? Such
Yes.
a wave which consists of series of compression and rarefaction, right जी? Such a wave which consists of the series of compression and rarefaction is called, इसको आप क्या कहते हैं? A longitudinal wave. Got it जी? Such a wave
Yes.
is known as a longitudinal wave. And in another scenario, you can also define the transverse wave. And how you're going to define that? That it is such a wave which consists of series of crusts and trough. Right? जी? Such a
Yes.
wave which consists of series of crust and trough is called, इसको आप क्या कहते हैं? Is called um, transverse wave. Is that clear जी?
Yes.
ठीक है. अब crust trough और compression rarefaction क्या होते हैं? You can see the part of the wave where the particles are very close to one another is known as a compression, and the part of the wave where the particles are very far away from one another, that is known as rarefaction. Is that clear?
Yes.
And what are the crust and the trough in the case of a transverse wave? So remember that the part of the wave above the mean line, यानी ये वाला part और ये वाला part. The part of the wave above the mean line is known as a crest, and the part of the wave below the mean line is known as a trough. Did you get that?
Yes.
So we've got the crust and we've got the trough. So remember that when you're talking about the series of crust and trough, that is known as a transverse wave. And when you're talking about the series of compressions and rarefactions, that is known as a longitudinal wave. Is that clear?
Yes.
अब वो definition, now let's talk about that definition which you need to write in the exam. Okay? अगर आप, for example, if you're talking about the longitudinal or the compressional wave, you were moving your wave in this direction, right?
Yes.
And you got to see that the particles were also moving in the same direction. मेरी बात समझ आई है?
Yes.
You were moving, you moved this back, you moved this wave forth. The wave moved in this direction, and the particles also vibrated in the same direction. Is that clear?
Yes.
So when the particle is going to move in the same direction as well, like this is going to be some sort of a, आप देख सकते हैं that the direction of wave, right? The direction of wave is parallel to vibration of wave. Is that clear?
Yes.
Direction of wave is parallel to the vibration of the wave. Is that clear?
Yes.
So that is how you need to talk about this thing. And secondly, whenever you're going to talk about this thing, what does if that mean in the case of a transverse wave? आपने wave को ऊपर की तरफ move किया था. At the first, you pushed this wave up. Remember? But the wave simply moved in this direction as well. So wave जो है वो move भी किस direction में की इस direction में. तो यहाँ पे क्या case हो सकता है simple सा कि जी direction of wave. अच्छा ये parallel कैसे sign होता है? Direction of wave is perpendicular to the vibration of wave particles, right ji?
Yes.
Direction of the wave is perpendicular to the vibration of the wave particle. That is how we're going to talk about this one. That is how we're going to talk about this one. अब वो definition लिखते हैं जो आपने exam hall में लिखनी है for the longitudinal and the transverse wave. So such a wave in which particles vibrate in a direction, particles vibrate in a direction parallel to the direction of flow of wave. Is that clear? Yani, this is such a
Yes.
wave in which particles vibrate in a direction parallel to the direction of flow of wave. Is that clear?
Yes.
Now, how would we define the transverse wave in the similar fashion? We're going to do that. It is such a wave in which particles vibrate in a direction perpendicular to the direction of flow of wave. Is that clear?
Yes.
So that is how you're going to define both of these types of waves. Okay. इनकी मुझे example दे दें. So remember that sound wave is an example of the longitudinal wave whenever you're talking about it, right? Sound wave is an example of the longitudinal wave. And whenever you're talking about the light waves, that is an example of the transverse wave. Remember कि sound कैसे travel करता है? First of all, it compresses the air particles like this, and then it open ups the air particles like that. ठीक है जी बात? So you've got compression, you've got rarefaction, and you've got compression. And how does the light travel? You've got this thing at the part as the photons, and direction travel must be this one. Got it? Ji?
Yes.
Okay, ji? So that is how you're going to talk about the light waves and somehow the sound waves. Is that clear? Ji?
Yes.
So that is how we need to talk about these types of waves. Is that clear?